Now we're going to decimal. Now we're going to multiply decimals. Here we go. We're going to do it with the area model again because I love the area model, and I also love Halloween colors, even though it's not coming unstuck. Okay, so 3.2 times 2.1. We know that that's got to be at least as big as this 3 by 2 rectangle for the area model. And the 3 by 2 rectangle area model, well, that's like a third grade area, right? 3 by 2 is 1, 2, 3, 4, 5, 6 square units of whatever it is. So we've got to be bigger than 6, which was the whole number parts 3 by 2. Okay, so it's got to be bigger than that. And it's 3.2, which is these little guys, and 2.1, which is that little guy, and we're going to do that in a minute. But we know it can't be as big as what the next biggest number would be. So the next biggest number for 3 is a 4, and the next biggest whole number for a 2 is a 3. Okay, so if we went over all the way from 3, instead of 3 point something, all the way to 4, and from 2 point something all the way to 3, then we'd have a 4 by 3 rectangle, which you can see through my little cheaty lines that I have underneath. And you can see that this would actually give us a 4 by 3, which is a 12 square unit shape. So we know that our answer is going to be somewhere between 6 and 12. Let's go ahead and calculate it more exactly. We've already got the whole number part for 3 by 2. We're going to go ahead and write out the FOIL stuff like we've done before a jillion. First, I wanted to rewrite this in a FOIL friendly way, and then an even more friendly way, because 0.2, I can't believe I even just said 0.2, because I don't like that. It's 2 tenths because it's in the tenths place, and 2 and 1 tenth here. So we're going to go ahead and do FOIL on this guy, and I'm going to show every single step this time. The first thing we do is 3 times 2, which gives us this 6 here, 6 right there. Then we're going to do, that was the first, now we're going to do the outer, 3 times 1 tenth, which for a lot of you, you're going to want 3 over 1 times 1 over 10, which is just 3 ones times 1 tenth. So that gives you 3 tenths. Then we're going to do our inner piece right here. Inner piece. Wouldn't we all like to have inner piece? Okay, so that's 2 tenths times 2, or 2 divided by 1, which is still 2. So here we get 4 tenths, which you can write as 2/5 if you feel like simplifying, but for me it's easier to just leave everything in the tenths since we want to go back to decimals eventually anyway. And then our last piece here is our 2 tenths times our 1 tenth, and when you multiply your decimals, you do 2 across 2 1/100ths. And then let's show where all that stuff comes from in our area model, and then we'll simplify and get our exact answer. So let's first look at the first piece we already did. This one, that was the 6, okay? And then we need to look at the 3 times the 1 tenth. Yeah, so let's look at the 1 tenth here. 1 tenth is just 1 little tenth. And you can see through, I can tell on the video, you can see through that there's 10 lines drawn out here underneath. So I'm going to go ahead and shade in the actual right color, unlike what I just did a moment ago that you can't see. So here we've got 3 times that 1 tenth. Okay, there's the 1 out of 10 little pieces of a width of 1, and we're shading in one of them. Well, across, this is 1 tenth, and we're going 1, 2, 3 is the length. So that's our 3 tenths, 3 times 1 tenth. Then we're going to go over whoops, as I make it all crooked, sorry about that. And we're going to do the 2/10 here. You can see again that I have underneath here already blocked off, just to save us a little bit of time. I've done 2/10, so there's 1, 2 wide. We're going 2 wide here, and we're going down all the way the length of 2. So we've got a width of 2/10 and a height of 2.
Hey Karen,
Yes, Ariel?
can I ask you a quick question?
Of course you can.
So I feel like some people might feel the need to continue on their coloring just like we do when we do the fraction bars. I feel like some people are going to want to take this red and go all the way over.
Okay.
But can you explain why they shouldn't do that and why they shouldn't go all the way down?
Well, there's no shouldn't. I'm just doing it different than I did last time. If you want to go ahead across, we're cool with that.
Oh, okay.
So it's not really anything different, and then you do get that overlap effect that we'll talk about in a minute. So that's fine. If you need to see all that going on at the same time, I'm cool with that.
But you're okay as well with them stopping at 3 and
Right.
2.
Yep.
Okay.
All good. All right. So here we have what I wrote as 2/10, which it's not, it's 4/10. This is 2/10 by 1, and this is 2/10 by 1. So each of them is 2/10. So together, this is our 4/10 piece in blue. Okay, and then here, this is the thing that gets a lot of people. Right here, we've got that double shaded thing that overlaps if you do it like Ariel was doing it. And I'm hoping you can still see through quite a bit to the paper that I have underneath here where I've already drawn the lines, because I really can't draw all those lines. That would be like insane. I can draw a couple of them. I'll draw this because this was 2/10, and that was just 1/10. So here we have two little squares filled in out of our whole 100 squares. If this is, because this is a 1 by 1 unit square here. So here, since it's 2/10 of 1/10. So it's 2/10 wide and 1/10 tall. So that gives us 2 1/100ths, because it's a tenth and a tenth. So since it's tenths times tenths, you get 100ths. Hopefully you can see that with the squares underneath, that we really get just 2 1/100ths there. And I think I shaded a little extra. I got kind of zealous when I was over shading there earlier, and that's why it's looking kind of funny to me. So we're going to fix that for a minute because it just looks a little out of sync. Okay, so I just did a little bit of erasing because I got overzealous when I was shading here, to show you that it really is 1/10 of the height and 2/10 of the width here, which gives us just those 2 100ths out of the whole thing. 2 100ths. Let me go ahead and mark off our whole area model here for this problem to make it clear where the area is coming from. Okay, and this whole like shading in the tenths and hundredths, it's like, I didn't want to draw those lines like I did with the fractions because it's really hard. I've done it, but it just gets so messy. So I cheated and put a grid underneath because I knew what I was getting at. So, but if there was more time, drawing in all those lines wouldn't be that horribly painful. I just wanted it to be to scale. So let's go ahead and get common denominators now and show what happens when we add up all our partial products. So here we go with our partial products. We need to get common denominators just like we did with the fraction problems. This time we're going to multiply by 10/10 and 10/10 here. And we get 6 plus 30 100ths plus 40 100ths plus 2 100ths, which is 6 plus 72 100ths. We could also have done that just in the decimal form, which I'll go ahead and write above. 6 and 72 100ths to be the proper mixed number, which we're actually doing a decimal problem, so I'm going to go ahead and do the decimal form. 6 plus 3/10 would have been the 0.3, plus 4/10 would have been a 0.4, 4/10, plus 2/100, 2/100. So this one just adds straight across, or we can add the partial products this way. 6 plus 0.3 plus 0.4 plus 0.02. I kind of on purpose made this one not too complicated. Okay, and a lot of you want to have your zeros here just to have everything line up. You could even write 6.0, have it all line up, and you get your 6, and just like below in fraction form, 72/100. So I hope this lets you see both the connection between the area model and FOIL and the fraction multiplication, and here with the decimal multiplication. Clearly, when we get to bigger decimals, we won't be able to easily make an area model for this, but with just tenths that turn into hundredths, it's manageable. So I hope seeing all this helped, and helped you understand where the estimate comes from too, because it really is, it's got to be bigger than just 3 times 2, but it's got to be smaller than the next whole numbers up, 4 by 3, which would give you the 12. Our area there has to be between those two. Okay, thank you for watching. Bye.